I was driving here this morning, and I was just relying completely on that little blue dot on my screen.
We all do.
I didn't question it at all. I didn't even really look out the window to check. I just trusted the map.
Mm-hmm.
But then I started reading through the material for today's deep dive, and I had this slightly unsettling thought. That map, it's not really reality.
It's definitely not.
It's a trick. A very, very useful, mathematically brilliant trick, but a trick. We're taking this huge, lumpy, spinning 3D rock and, trying to smash it flat onto a 2D screen.
And you just can't do that without lying a little bit.
Lying.
That's really the fundamental paradox of cartography. I mean, to make a map useful, you have to distort the truth. If you made a one-to-one representation, well, it wouldn't be a map, it would just be the Earth again.
Right.
So a map is, by definition, a selection. It emphasizes some things, and it just completely deletes others. It's a curated deception, really, designed to help us get from A to B.
A curated deception. Wow, that is a strong way to put it. Okay, so today, we are peeling back the layers of that deception.
We are.
We're going to dig into what actually goes into making a map, the so-called map maker's art. And we're going to find out why your GPS might technically be disagreeing with a historical landmark and why a map is totally different from a chart.
I think it's going to change the way you look at Google Maps forever.
I believe it. Okay, so let's start with the basics. The material we read talks about the 5 ingredients of a map. It sounds like a recipe.
Just a bit more complicated than a cake.
I would hope it helps.
And the order really matters. So the first ingredient is the reference system.
Okay.
This is just the language we use to talk about location. So, latitude and longitude.
The grid.
The grid, exactly. But then you hit the second ingredient, and, well, this is where things start to get a little messy. The datum.
Okay, I've heard this word, but I have to be honest, I never really understood what it is. Is it? Is it just the math part?
Think of it like this. The reference system, lat and long, that's like a net you want to throw over the Earth.
Okay.
But the Earth isn't a perfect sphere. It's kind of lumpy. It's squashed at the poles, and it bulges at the equator. It's more like a potato.
Potato, I like that.
A geoid is the technical term, but yes, a potato. The datum is the mathematical model, the set of rules that decides how we drape that net over our potato. It anchors the coordinate system to the physical Earth.
Ah.
And here's the kicker. Different countries, different eras, they've all used different datums, so they've anchored the net in slightly different places.
So wait. If I use an old map with an old datum and you use a brand new map with a modern datum,
our coordinates won't match. We could be talking about the exact same numbers, the same latitude and longitude, but on the ground, we could be hundreds of meters apart.
that seems like a really big problem.
It can be. Then, of course, you have the measurement system to calculate those coordinates. And then number 4, the one that really breaks people's brains, projection.
That's the flattening part, right? The orange peel.
That's it. Imagine peeling an orange in one piece. Now, try to press that peel perfectly flat on a table without, tearing it or squashing it.
You can't do it.
It's physically impossible. That's projection. You have to choose what to distort. Do you want to keep the shapes of countries correct?
Sure.
Well, then their sizes will be all wrong. The classic example is Greenland looking as big as Africa on some maps.
Right.
Or do you want the sizes to be right? Then the shapes get all weird. Every projection is a compromise.
And what was the 5th ingredient?
That's the map maker's art. The visuals, the colors, the symbols, the line weights, that's where the human element really comes in.
Okay, I want to go back to that second one, the datum, because it leads to one of the wildest things in this deep dive, the Greenwich lie.
Ah, yes. The case of the shifting prime meridian. It's a great story.
So everyone knows Greenwich in London. It's the home of time. 0 degrees longitude. There was a literal line on the ground there at the Royal Observatory.
Tourists love it.
Right. They straddle the line, 1 foot in the east, 1 in the west. They take a selfie.
It's the classic photo op.
But if I'm standing right on that physical line and I pull out my phone and look at my GPS coordinates, what happens?
Your phone will very politely inform you that you are not at 0 degrees. It will say you're about 102.5 meters west of 0.
That's not a small error. That's the length of a football field.
It's a huge gap, and it confuses people all the time. They think their phone is broken or that the GPS satellites are, drifting.
So what happened? Did they build the monument in the wrong place?
No, the monument is exactly where it's always been. The math moved.
The math moved.
The historic line, the one tourists stand on, is called the Airy Transit. It was established back to 1851 by Sir George Airy, and he basically just pointed a telescope at a specific star and said, okay, this line right here, This is 0. It was an optical measurement anchored to the ground in London.
Which makes sense for 1851.
It does. But modern GPS doesn't use a telescope in London. It uses something called the WGS-84 datum.
Right. And that system is geocentric. It cares about the center of mass of the entire Earth. It's looking at the whole potato, so to speak, from space. And when you calculate the prime meridian based on the planet's actual center of mass, well, the line shifts.
So the real 0 is now, what, cutting through a park about 100 meters away?
Exactly. I think there's a trash can that more or less marks the spot, but it just goes to show you 0 isn't a physical thing. It's a construct. And when we change the datum, the construct moves.
That is going to bother me every time I use a map now.
Sure.
But okay, let's move from these invisible lines to very visible ones. Let's talk about topographic maps.
Sure.
This is what I think of when someone says a real map, the ones with all the squiggly lines.
Absolutely. These are the workhorses. A topographic map, or topo map, is designed to show you the landscape, both the natural stuff and the man-made stuff. But its superpower is showing you the third dimension, elevation.
And it does that with contour lines. The humble contour line. It's such a brilliant invention. It's just a line that connects points of equal height.
And the rule is simple.
The rule is simple. If the lines are all bunched up and tight, you're looking at a cliff or a very steep hill.
Yeah.
If they're spread out, lazy, then you're on pretty flat ground.
I loved the part of the material that takes us on a little tour of Australia to illustrate this. It really shows how different landscapes can, feel on paper.
It's a great way to learn to visualize.
Okay, so let's start with Sydney, the Manly region specifically. If I put a topo map of Manly down in front of you, what do you see?
Chaos. Controlled chaos. You see a lot of cultural detail. That's the cartographer's term for anything man-made.
Okay.
So black squares for buildings, dense road networks. But underneath all that, the contour lines are tight and they're wiggly. It tells you immediately this is a dense city built on rugged, hilly terrain right up against the ocean. It just looks busy.
Now let's go to the complete opposite, the Pilbara.
Yeah, total opposite. The Pilbara is ancient, dry country. So the first thing you notice is just the color. Because there's so little vegetation, the map doesn't have to hide anything. You see these really clear brown contour lines forming ranges.
Like spines.
Exactly. Spines of hills just running across the paper.
It sounds empty.
It is. The settlement details are so sparse. You might see a mine, a road, maybe a single railway line. It feels open. You can almost feel the heat coming off the page. The map isn't cluttered by people. It's dominated by geology.
Then we move to the Weed and Sheep area north of Perth.
Right. And this is a landscape that's been tamed by humans. The contours are very far apart. So, gentle rolling slopes. But the defining feature here is the grid.
Little roads.
The road network, it just cuts the land into perfect squares and rectangles for farming. It looks like a lot of the American Midwest or the Canadian prairies.
Right, that same logic.
Broadacre farming. The map looks calm, organized, almost rhythmic. It's not the rugged chaos of Sydney or the raw geology of the Pilbara. It's like a factory floor for food.
And then the last one, which seemed the hardest to read, Darwin, the wet tropical example.
Darwin is tricky. It's really, really flat, so you don't get many helpful contour lines to give you a sense of the shape of the land.
So what dominates the map?
Vegetation. You get light green for forests, and then this really dense, dark green for mangroves along the coast. And the notes mention that the vegetation can actually make it harder to see what little elevation there is.
Yeah, that's right.
So the map maker has to make a choice. And in a place like Darwin, the mangroves are a huge navigational barrier. You can't just walk through them. So showing the mangroves becomes more important than showing the exact height of a mudflat.
That makes sense.
The whole map just feels heavy, organic, almost humid. And because the housing is so dense in the city itself, they don't even try to draw individual buildings. They just wash the whole area in pink.
The built-up area.
Exactly. It's just a shorthand.
So we have all these incredibly detailed maps for every corner of the country. But that brings up a logistical question. Australia is huge. The U.S. is huge. If you have thousands of these rectangular maps, how do you organize them? How do I know which one to buy?
That is the series mapping problem. And you're right. If you just tossed all 3,066 of the 1,100,000 scale maps for Australia into a big pile, you would never find anything.
So there has to be a system.
A very clever one, the International Map of the World, or IMW. It's basically a massive grid system for the entire planet.
I saw these codes in the notes. They look like license plates, something like SJFOC6.
It's a coordinate code, and it's actually quite elegant. The first letter, S, tells you the hemisphere south.
Okay.
The second letter, J, tells you the latitude band. And the number 56 is the longitude zone. So SJ56 is just a big box on the Earth's surface.
And then they just nest the smaller maps inside that bigger box.
Like Russian nesting dolls, or like zooming in on a digital map. You take that big SJ56 box and you slice it into 12 smaller rectangles for the next scale down. Then you slice those into even smaller ones.
So every square inch of the country has a unique address.
Exactly. It satisfies the compulsive organizer in all of us.
Now, I want to pivot to a distinction that, I'll be honest, I get wrong all the time. I just say map for everything.
A lot of people do.
But if I'm on a boat or on a plane, I'm supposed to say chart. Is that just, professional snobbery, or is there a real difference?
Oh, it's a critical life or death difference. A map, generally speaking, is about the land. It focuses on what is there: roads, towns, hills. On a standard map, the water is usually just a blank blue space. It's negative space.
Okay, and a chart.
A chart is about navigating through a medium so, water for ships, air for planes, and its primary obsession is safety.
Safety.
A marine chart couldn't care less if there's a lovely cafe on the coast. It cares if there is a rock just below the surface that will rip your hull open.
So a map shows you where to go, and a chart shows you what not to hit.
That is a perfect way to put it. Charts show bathymetry depth lines. They show lighthouses, buoys, strong tides. They're actually legally distinct documents. If you crash an oil tanker because you were navigating with a road map, you are in serious trouble.
And this applies to the sky, too.
Absolutely. The sky is an ocean of air. So aeronautical charts are all about navigating hazards, things like radio towers, mountain peaks, restricted airspace.
And this is where we see that clash you mentioned, between the perfect math of the grid and the reality of flying a plane.
Right. This is the difference between the IMW system we just talked about and the WAC.
The World Aeronautical Charts.
Exactly. Now, remember our IMW grid, SJ56, perfect, rigid, mathematical squares?
Right.
But imagine you're a pilot flying along the coast, and the perfect grid line just happens to slice off a tiny peninsula or a river mouth that you're using as a key landmark.
That would be so annoying. You'd have to fumble around for the next map just to see the last 5 miles of the river.
And fumbling is dangerous in a cockpit. So the WAC system cheats. It takes that perfect grid and it stretches it.
I loved the analogy in the notes for this. It's the difference between tiling a floor and laying a rug.
Yes. The IMW is the tiled floor-perfect, rigid squares. The WAC is a rug. If the rug doesn't quite cover the important bit of the floor, the landmass, you just drag the rug over a bit to make it fit better.
The example was the Roper River map.
That's the one. In the rigid grid, the map cuts off the river mouth, but nearby there's a big island, Groot Island. So the aeronautical chart makers just shifted the whole map boundary to the east.
To get everything in one view.
They expanded it to include the whole island and the river mouth, and then they renamed it the Groot Island chart. It's purely pragmatic. It prioritizes the user over mathematical purity.
It's just so interesting how we think of maps as these objective scientific things, but so often it just comes down to a human making a choice about what's useful.
Always. Every time.
Which is a perfect lead-in to our final category. Thematic maps. If topo maps are the encyclopedias, these feel more like the storybooks.
That's a perfect distinction. A topo map tries to show you everything at once. A thematic map strips almost all of that away to show you one specific thing. It is a narrative, a point it's trying to make.
And the examples were so varied. You had one on limestone caves in Tasmania.
Which is so minimal. It's just a blank background with some dots on it. It doesn't care about roads or towns. It just answers one single question. Where are the holes in the ground?
And then you had the coal exports map.
That one's fascinating because the geography is almost irrelevant, isn't it?
Yeah.
It's just a background for these giant red arrows pointing to Japan and Europe. It's a map about economics, about flow, not really about place.
And then the political one.
Huh.
Maritime boundaries.
Now, this is where maps become law. The guide showed 2 different maps of Australia's ocean territory. One showed the territorial sea, the 12 nautical miles that are sovereign territory. The other showed the exclusive economic zone, which goes all the way out to 200 nautical miles.
They look like completely different countries on the map.
They essentially are. One is the country where your laws apply. The other is the country where your fishing rights apply. The map literally defines the reality of the state.
And even something as simple as a tourist map fits in here,
Well,
right?
absolutely. A tourist map is one of the most heavily curated, most thematic maps you'll ever see. It's technically a general reference map, but it's been sanitized.
Sanitize.
It highlights the scenic lookout, but it conveniently deletes the sewage treatment plant right next to it.
It's marketing.
It is. It's a thematic map where the theme is basically have a nice time and don't look over there.
So we've covered a lot of ground today, literally. We've gone from the shifting math of the datum to the life-saving details of a marine chart to the rug pulling of aeronautical maps.
Mm-hmm.
It really does change how you see the world.
It does. I think the biggest takeaway, for me at least, is that there really is no such thing as a neutral map.
How do you mean?
Well, every single map you have ever looked at is the result of 1,000 tiny decisions. Someone decided which projection to use, which automatically distorts your view of the world in a certain way.
Right.
Someone decided which datum to anchor it to. Someone decided to include that road but leave out that little footpath.
Or to show the mangroves instead of the mud.
Exactly. When you look at a map, you aren't just seeing the world. You are seeing a human being's interpretation of the world.
That brings me to a final thought I wanted to run by you. We talk about how the datum changes over time, right? How coordinates shift because of better math and continental drift.
Mhm.
And we know maps are just these selected realities. So
Yeah.
is it fair to say that every map is really just a snapshot of a specific moment in time? That a map isn't really about where, but it's actually about when?
That is a really profound way to think about it, yes. The Earth is moving under our feet. The coastlines are eroding, the magnetic poles are wandering, the cities are expanding. A map is a fossil. The moment it's printed, it's already becoming history.
So the next time you open up Google Maps or unfold a hiking map, what's the one question you think the listeners should be asking themselves?
Don't just ask, where am I? Ask, what is this map maker trying to show me? And maybe more importantly, what are they hiding? Because usually the stuff they left out is just as interesting as the stuff they put in.
A healthy dose of skepticism for the little blue dot.
Always.
I love it. Thanks for helping us decode all the lines today.
It was my pleasure.
And thank you for listening. We'll see you on the next Deep Dive.